because actually it wasn't too difficult to have spotted that in advance. Had no one thought about the technical requirements of the product? Because they hadn't, right? In other words, there were systematic failures all the way through the project. I couldn't understand why. But the other thing I couldn't understand about this project was what was going on. Who was kind of running it? So eventually I remember talking to a manager and saying, well, who was actually running this project? Who was in charge? And the guy said, well, I don't really know. I suppose I was, really. I said, that's funny, because I asked another bloke the same question last week, and he said he was. In fact, I asked 5 different people who was in charge of that project, and they all kind of said, well, I don't really know, but it could have been me, right? And that's a situation, that's a telltale situation that no one is managing the project properly. And if no one is managing the project properly, all of the other stuff I'm going to talk to you about in all the other lectures, the market research, the finance, just doesn't get done properly. Usually because it's not my job. Well, it wasn't my job to do it. Whose job was it? Well, I don't really know, right? And project management is all about avoiding that situation. Right? Project management is a discipline. You can get degrees in project management. You can get diplomas in project management. You can get a 2-week qualification in Prince 2 at least one university here in Edinburgh for a very reasonable sum, and you can call yourself a project manager. It's a process for achieving better results. It is very much a transferable skill, because project management isn't just about bringing commercial projects to market. It's about doing anything where you have a process, something that starts and something that stops. Writing a research grant, doing the research grant, building an extension to your house, building a new parliament for Scotland, building a tram system, right? All these things are examples of project management. Right? If you say project management to quite a lot of people, they say, oh yes, it's project management software, it's Gantt charts, okay? And actually, it's not, right? You may or may not know what a Gantt chart is, and I'll show you later. It's not. It's all about the way that you actually work. When do we need project management? We need project management when we've got something that has a specific start and finish date. We need it done by this time. Okay? We tend to have limited budgets. We have set outputs and requirements. We need to get this pharmaceutical to market, and it mustn't kill anyone, as well as cure them. We need to get this play actually first night performing at the Lyceum Theatre on December the 21st, and all the actors have to have their costume. Right? And the other characteristic of project management is a complexity, a multiplicity of tasks. It's not just about your own particular discipline. You might spend quite a lot of time on the phone just talking to people. You might spend a lot of time setting up meetings. You might set up a technical specification, but you also spend a lot of time dealing with contracts, contractors, right? If you don't have the right piece of machinery, your project can be delayed. If you don't have the right employee, your project can be delayed, right? So all of these multiplicity of things constitute the totality of a project, right? And at this stage, it doesn't really matter what the project is, but that can be true. The history of project management goes back to arguably the 1950s, possibly even before. But in the 1950s, a number of the techniques were developed by the American military, mostly because the Russians put a satellite in orbit. And various people in America did a calculation of the size of rocket you needed to put a satellite into orbit, and realized that rocket could very easily fly things from Siberia to the mainland USA. Right? America had been caught out. America needed to catch up. And what they wanted to do was to spend more time and money on successful projects, largely defense projects, and spend less time on unsuccessful projects. And if any of you are students of military history, you'll know that this is something that the defense industry still struggles with today. Right? And in particular, what they wanted to do was to develop a system that was transparent in terms of progress, so that managers, politicians, civil servants could see how far have you actually got. What percentage completion are you? And if you're late, well, why? What's going on? Is it someone's fault, or was it unavoidable? But we do need to know that stuff. And one of the things you can do is find some splendid examples of situation where project management hasn't really worked. So there was an early warning radar system, the Nimrod, right? You can go and look that up on the internet as to how many years, or actually decades, that was late. Same thing, the first computerization of the UK air traffic control system. The London Stock Exchange's first electronic trading system, Philips. Does anyone remember video recorders? VCRs, Betamax, right? Does anyone actually remember that the people who invented the first one was Philips? It just took them 8 years to produce the second generation model, by which time both JVC and Sony had overtaken them by 3 generations. And of course, I could mention British industry. I could mention Apple in the 1990s, before Steve Jobs came back. Very nice computers, organizational disaster. Never had the right computer. They didn't order, they announced new models but couldn't actually fulfill the orders. They stopped the model you wanted just as you were about to buy it. Bit of a disaster. And of course, here in Scotland, we have 1 or 2 absolutely classic and wonderful examples of utter project failure. And if you do want a good read sometime, I could strongly suggest that you read the report on the building of our wonderful Parliament, which is very nice. It was scheduled to cost £40 million, and it ended up costing £400 million. And one of the things you'll find is they did have a project manager, but he left in disgust fairly early on in the project. And after that, it was a question of who's in charge now. I won't even mention our tram system, except go to Sheffield, where they have a very nice tram system, if you want to see what it could be like. On the other hand, we do have organizations that are consistently good at managing projects. We have commercial companies like Hewlett-Packard, Canon and Xerox for years and years and years. If you were a manager at Hewlett-Packard, you weren't just judged on the profitability of your business stream, you were judged on how much of the profit came from products that had been introduced in the last 2 or 3 years. You couldn't just sit on what we call a cash cow and let the money come in. You had to consistently innovate. I've already mentioned theatre companies. If you do a degree in theatre management, right, an awful lot of what you learn about is project management. That's what the producer on a movie does. If you want an insight to what happens on a movie, then I could recommend getting the Lord of the Rings box set, the extended edition. Don't watch all the rubbish, all the story. Just watch how they made the movie, how they had to get 400 people to locations in the middle of New Zealand with all the right costumes, with all the right film equipment, with all the right actors. So it was a massive piece of project management. The building industry, when it's not building parliaments, the building industry usually does manage to get buildings built on time and on budget. The Apollo space program, that's a good example. President Kennedy stood up in 1961 and said, we will put a man on the moon by the end of the decade. And that is pretty much a drop-dead deadline, okay? That's committing yourself. Desert Storm, okay, you may or may not have various opinions on the desirability of invading Iraq or invading foreign countries far away. But if you think about the logistics of trying to get 250,000 soldiers to a barren patch of desert somewhere in North Saudi Arabia, getting them fed 3 times a day, every single day, getting all the equipment there, getting all the ammunition there, getting all the tents, air conditioning all the computers. Did you know the Americans spend more money on air conditioning than Britain spends on its total defense, right? Air conditioning all their computers, right? The logistics of doing military things are extraordinary, right? And if you want to see how that doesn't work, read about Napoleon in Russia in 1812. Okay. We have some organizations that are very good at doing long-term project management, like the pharmaceutical industry, where projects last for 5, 15 years, something like that. And we have at the other extreme something like the Formula One industry, where they design a new car in 3 months, and they keep developing that new car, and in between every Grand Prix race, they develop new things, which they're not even allowed to test now. When Michael Schumacher went to Ferrari, he was the best driver, but he also insisted in putting the best team around him, the best designer, and in particular, he insisted on hiring Ross Brawn, who now runs the Honda team. Ross Brawn is basically a superb project manager, right? That's what he does really well. Okay, and what are the lessons that we can get from watching those people, right? What do they do? Well, one of the things they do is they actually have a process for deciding which projects to do, right? They make good decisions. The other thing they do, the next thing they do, is they actually do have a project manager. And if he leaves in disgust, like the project manager of the Scottish Parliament, they appoint another one, right? They have a project manager, they put the project manager in charge. They break things into stages, into doable chunks, and they manage those stages. They manage by deadlines and deliverables, right? You can have some more money if you get to this point. You don't get more money just for passing go. You don't get more money because it's in next year's budget. So true project management isn't about annual budgets. Good project managers are very good at communication and are very good with people. Talking about Ross Brawn again, any Formula One fans here? Do you remember when his team, he took over the Honda team and it won the World Championship? And as Jenson Button passed the finishing line, a BBC reporter stuck a microphone in front of Ross Brawn and said, "Ross, what would you like to say?" He said, "I'd really like to thank all the people that work for our team, especially the ones who designed the car, but then we had to make redundant 9 months ago, right? Because we couldn't afford them, right?" That was the first thing he said in his moment of triumph, right? That's a man who is really, really good with people. That's a man that people will fight to work for, right? That's a good project manager. They communicate well, they know the risks, they review, and they will stop failing projects. One of the key things they do is they stop projects. And at my old company, the only way we had of stopping projects was basically me doing a post-project review. Right? We basically didn't stop projects. But if Kevin came round, I mean, I might as well have had the black cloak and the scythe. But that was the only process that we had. Right? And they have a number of methodologies, one of which is Prince2, that helps them do that. So, new project process. The best companies have a process for deciding which project to do. You could call it a meta process, if you like. They'll typically ask for ideas. They'll typically ask their people to generate lots of ideas, but they won't do all the ideas, right? They'll have some kind of concept test, right? They'll take some of the ideas they really like and do a little bit more work on them. A sanity check, a risk assessment, a feasibility study. And not all of the projects will pass that feasibility study. And some of them will get through and they'll do a full development project, which they may manage using something like a Prince2 process. So they've always got a funnel of ideas. They've always got more ideas that they could do than they actually have underway, which is why they're able to stop bad projects early. They take the view, it doesn't matter if we stop a project, because actually we've got a whole stack of other good ideas. We employ good people. We have good ideas. We've got more ideas than we can actually manage. So you get something like this. You have some kind of process where you encourage people to have ideas. You might have proof of principle studies. You might have a feasibility study. You might have a development project. You might, if it's a commercial project, be doing detailed market research right the way down to actually putting a full business plan and finance and launching it into the world one way or another. Right? And the advantage of that kind of process is you know why you're doing it. You know what the risks are because you're doing risk analysis at every stage. You know that if you stop the project, you've got some other good ones to take its place. And what this does, it actually encourages your people to be creative. In the chemical industry, you will hear people talk about stage gate processes. Stage gate processes was a generic process devised by a guy called Professor Robert Cooper. Robert Cooper wrote a really good book called Winning at New Products in 1990. It's still in print now. He took something like 300 pairs of projects, good ones, in, say, the chemical industry, and a bad one in the chemical industry. Good one in the computer industry and a bad one, and he compared the factors, right? And quite a lot of the insight that and the improvement that there has been in project management, especially in the chemical industry over the years, comes from this guy. Certainly when I started reading the area, it was one of the few business academic textbooks that actually dealt with real processes rather than conceptual and strategic things. So stage gate processes are used by lots of UK and US chemistry-based companies. I did some market research before devising this program in the autumn and talked to 4 or 5 companies, including Procter & Gamble and Syngenta, Unilever. They all use something like a stage gate system. So the project goes through numerous phases from idea to actual launch, whatever your launch is. Okay? And the phases are made explicit, and you have to do specific things to get through the gates. Right? If you Google stage gates systems, and you'll see that there's dozens of them, and they all have beautiful little schematics like this. And every company delights in making its own wonderful schematics. Okay? What you also will hear about is people talking about Prince 2, particularly in the defense industry and electronics industry. Prince 2, I guess you could summarize it by saying stage gate helps you decide which projects to do, and Prince 2 helps you to manage the ones that you do. Okay? And that's a massive oversimplification because you can blur this. Okay? It's used extensively by the government, by the private sector, and the method is in the public domain. Prince 2 is basically codified common sense. They have a focus on objectives. They have a focus on reasons why you're doing this project. They have a focus on benefits, remember, which we talked about in our lectures last week, markets. Right? They have a focus on a project team doing the work and a separate team actually assessing the quality of the work. And I said it's codified common sense because you can go onto the internet, you can find Prince 2 forms, and they look incredibly bureaucratic. They are, okay? but they're quite good. In a sensible project, you would agree that the project manager should go and talk to the sponsor, the funding agency, the client, and say, what do you want? Right? That seems sensible? Actually, it doesn't always happen, but it seems a sensible thing to do, doesn't it? Right? In Prince 2, you have to do it. It's called the project mandate meeting. You get the project mandate forms. You write down what you decided. Right, so this is what we want, say the clients. I agree, says the project manager, and they both sign it. Right? Codified common sense. It's then quite sensible if the project manager sits down with the whole team and says, look, team, this is what we've got to do. I want you to do this bit, you to do this bit, you to... Do you understand what I'm asking you to do? Good, right, sign here. Right, that's called a project initiation document. Right? It's just codified common sense. I said you could go on a Prince 2 course, and basically it's teaching you how to use those documents. Systematic approach to documentation, that's probably the understatement of the year. I have been in some organizations where they basically needed a project mandate meeting before they'd go to lunch. But it actually is quite a good system. You can adapt it, you can kick it around, you can devise your own forms. But that's a schematic of the whole thing, the different stages, and you have documents for starting a project, deciding what to do, documents for initiating, that's briefing the team. You break the project into stages. You have documents for managing the stage boundaries. The box at the top that says directing the project, that's what the project management does. The box at the very top that says corporate or program management, that's the bosses saying, how are you getting on with this project? One of the things you might be asking if you ever find yourselves in large complex projects, might be in a commercial project, might be a large piece of research, European research with lots of interested parties, lots of participants. You might be asking questions like, who's actually in charge of this? Is anyone setting objectives? Do we have any kind of project management in place? Does anyone on the project know about Prince 2? Right? It may not be your job to be that project manager, but as a member of the team, I think it's quite fair to ask those questions. And what we try to do is break the project into stages, and we identify new stages where the resource requirements increase, or where the nature of the technology changes, or where the activities change in character. For example, going from lab scale to pilot plant scale. In general, we try and design our stages to find out things that are very high risk first, and things that are cheap first. So a classic example was you don't do a piece of drug development that costs billions of pounds and might last 10 years without checking to see what patents are out there. Right? That's a classic example of something that is cheap to do and reduces the risk of the project. Oh look, someone else has got patents in this area. Okay, stop there. We don't do the project. And we keep testing the idea and the technology as we go through the project. So typical processes. At the idea stage, what are you looking for? You are looking for people to be as creative as possible. You want them to express the main features of the idea. What is it you'd like to do? I'd like to go and do 3 Lord of the Rings movies in New Zealand. Great idea, fantastic, guy's mad. Okay? I'd like to develop a new antibiotic. Right? I'd like to build an extension to my parliament. Right? That kind of thing. Potential buyers, potential users, potential technical solution, potential resource requirements. Okay. Off the top of my head, I reckon this would take us a couple of years and cost us £5 million, right? Do I have your permission to do a quick study to see if that would work? Okay. And again, organizations should have loads of these, right? They should have loads of ideas floating around so that the management can say, yeah, that sounds good. If we get some resources, we get a little grant, we'll actually let you do a proof of principle study. Otherwise known as back of the fume cupboard experiments. You still do those, don't you? Yeah. Proof of principle, what is it? It's when you do sufficient technical or scientific work to show that the technology targets are achievable. Yeah. We thought we might be able to develop this ligand that separates lanthanides from actinides, and oh yeah, it looks that we can. That's good, isn't it? Right? We've just done it in a test tube in the back of the lab, but we have proven that that works. Right? What would you then do? Well, the science looks like it's working. Let's do a feasibility study. Let's check it out. Let's see if it still looks interesting. Does it look profitable? Does it look legal? Does it look achievable? And at this point, it's a good idea to switch your brain from being very creative, very enthusiastic, to, okay, this seems a good idea. Let's see if we can kill it. Right? Writing a feasibility study is trying to find all the reasons that the project might not work. Right? All of the downsides, because if we can do that with a project, if we can think of 10 reasons why the project might not work and it passes them, then, well, actually, we've got quite a robust project. If we've thought of 10 reasons why it might not work and it passes 8 of them and 2 are uncertain, then, well, those are the 2 that we actually need to keep an eye on and manage through the project. Yeah. And the output of a feasibility study might be, okay, let's spend some money, right? Let's see if we really can develop this thing. Let's put a development project together. We're doing some technical work to develop some kind of saleable product or saleable process. If it's a new process, we might be looking at scale up. Right? If it's a product, we might also be looking at the packaging. Right? Pharmaceutical industry spends a lot of time and money trying to work out whether to put drugs in bottles or in nice little silver foils like this one. Right? Will we have quality targets? Yes, we will. Will we have safety targets? Will we have user specifications? Will we have cost targets? And usually, in a good project, while the development is going on, there are people actively doing market research, finding out what potential users might want, because what that does is generates a whole new load of technical targets. Yeah, they'll buy it, but it's got to be green. Yeah, well, have your instrument, but by the way, it's got a laser in it, hasn't it? Yes. It doesn't interfere with anything else in the building, does it? Switch off other instrument. Yeah, well, yes, it does, yes. And we better screen it, right? Talking to users tends to generate new targets. And you tend to do that in parallel. And what you then do, you get a development project, and if both those things work, the development project and market research, then you progress to a full business plan. Yeah, we're going to launch a new product. There's the market research phase. There's the business plan. Detailed financial analysis of costs, right? All we've done at the moment is develop something which we might launch, right? We still might not launch it. It still might not work, right? So we are going to look at a detailed analysis of the costs, the income, the timings, the profits, the cash, okay? And there's a thing I'm going to talk about tomorrow called cash flow budgets and discounted cash flow budgets, which actually lets us get a handle on what these kind of things are worth, right? What's it worth? This project might get us £5 million in 5 years' time. But there's another project over here that'll get us £2 million in 3 years' time, which is better. Right? So there are tools for doing that. So the theory is that you break your project into stages. You do a number of set specific activities. You give people more budget when they complete those activities, not just because it's the end of year or the end of term or whatever. Each stage is quite multidisciplinary. You can imagine a chemical development process, but you could imagine that there would be IT people working on it. You could imagine there'd be chemical engineers working on it. There might be customer liaison people working on it. There might be safety people working on it. You might have to recruit new people, so you've got your HR department involved in the project. It's multidisciplinary. Each stage usually gets more and more expensive. And at each stage, the team and the senior management review it objectively and say, is it still worthwhile going forward? Right? Real life, that's theory. Okay, real life, what kind of things do you get? Okay, well, one of the things you can do with chemistry is develop new drugs, new pharmaceuticals. Right? What are the big stages in pharmaceutical development? It's clinical trials. You might have a candidate molecule. You might spend 5 or 10 years on drug discovery and preclinical work, but the big stage is phase 1. Do safety testing. Does your new drug actually poison people? You do that on 20 to 80 human beings, right? This is not animal testing. This is not torturing bunnies. This is real people. And that's going to take you at least a year and cost you at least £1 million. If that works, you might do phase 2, and phase 2 can be split up, subdivided. Efficacy testing. Does it actually work? Do double-blind tests against a control group. 100 to 300 subjects, a couple of years, we're talking tens of millions of pounds. Right? Phase 3, large trials, efficacy testing. Not only is it better than a control group, but is it better than the other drugs that are out there? What kind of dosages do we really get? Let's really try and pick up what we think the side effects might be. And let's not just run a test for Anglo-Saxons in Scotland, right? Let's run a test in Malaysia. Let's run a test in Japan. Let's run a test in Africa, right? Because different people have different reactions. 1,000 to 3,000 people, right? Years. 30 million, 50 million, 80 million, 100 million, okay? That's the kind of staging you're going to have to grapple with if you've invented a new pharmaceutical. You've also got patents going on in parallel. You've got stages of the patent application process. And if you put in patents, it's quite easy to put in the first application. It doesn't cost you very much. A few £100, a bit of research, a friendly patent lawyer, and of course the university has lots of those. By the time you get to PCT, Patent Cooperation Treaty, you're looking at, oh, okay. It's the nearest thing you have to an international patent. There aren't international patents, but you can do the first thing up to PCT, and you've spent about £5,000. 30 months on, you're thinking, okay, is this really worth something? Well, I better patent it. And of course, at the moment, you still have to have separate patents in every single country that you want to protect your invention in. And roughly, it costs you £30,000 for every country you want to patent in. And there are roughly 200 countries in the world, right? You could imagine wanting to stage that process. You might not want to spend hundreds of thousands of pounds on patenting things, for example, unless you're pretty sure that the thing works. And then you have a commercial process going on. It might be that you're going to start a company and take your drug all the way to market, but it might not, right? Having seen those numbers, you might just say, okay, we'll do a deal with Glaxo or someone like that. Yeah. The commercial process, how long does it take to identify and cultivate potential partners? We're in discussions with Glaxo. It's not, oh, I've got a friend at Glaxo and we talk in the pub, right? It's having real substantive discussions, firstly with the R&D department at Glaxo, secondly their commercial people, thirdly the people who know what kind of products they're looking for, right? Have you ever seen the organigram of some of these large companies? Right? Actually, just finding the right person that you should be talking to can take you ages. They all have the most astonishingly confusing titles. It's quite possible to have a vice president of European marketing and the European marketing vice president. And which one do you speak to? You get them to the stage where they're actually interested. What do you have to do? You have to have discussions under confidentiality, because you're still trying to patent it. That's a legal agreement, so that's going to go backwards and forwards. If all goes well and they say, yeah, we love this thing, you will negotiate an outline agreement with them. It's called a heads of agreement, and then send it off to the lawyers for detailed drafting. If all goes well, the first part of the process might take 12 months. The next part of the process might take 12 months. If you're working with really big bureaucratic companies, add on another 12 months. If you're working on with a company that's outside Europe where you've got time zone differences, cultural differences, probably add on another 12 months. I recall a guy at a small company investment conference talking a couple of years ago. He was selling software. He was selling software for the car industry. He was selling software to Motorola, who were going to put it on their chips. Motorola's chips were going into Bosch fuel injection systems. Bosch fuel injection systems were going into Fords and Mercedes. He was having to do this process with Motorola and with Bosch and with the car companies. Chemical scale up. Yep. It's pretty easy to do something in the lab in glass. You know, what could be hard about doing it in bulk? Well, you might want to take up, you know, the synthesis stages. You've got a wonderful 12-step synthesis. It's a work of art. It's beautiful. I've read about it in Chemistry World, but that's not commercializable, right? They're not going to actually implement anything that's got much more than 4 stages. You just lob in your stuff, you know, 1 mole of this and 1 mole of that. They've got to have one of the reactants in this big tank and the other one coming in gradually, which means the stoichiometry of the reaction is changing all the time. So it's quite conceivable that you make more intermediate products than you first thought and less of your desired product. Your little reactor is very easy to stir, very easy to do phase transfer catalyst. They've got a big reactor with lots of bulk liquids, not so much interface. And the surface area to volume ratio, right? You've got an exothermic reaction in your beaker, you slip an ice bath around it. They've got a big tank of metal full of hot reagents. Runaway exothermic reactions are the major cause of chemical accidents in the real world, right? They've got all those things to do. And one of the things you find in scale-up processes is it's rarely a linear process. There's always a feedback loop like the one I've drawn. Anyway, you have those stages, right? There are natural points to end the stage, right? Some of the ones I've just indicated, but some of the examples here. Right? We're going from computer modeling to physical prototyping. We're going from lab scale to a pilot plant. Okay? Any point where you suddenly need a lot more money is a natural stage end. Right? When you've completed something, that's a natural stage end. What do? You produce a status report. You say, these are the things that we have achieved. And a piece of project management jargon, you'll hear people talk about milestones. One of our milestones was to do a feasibility study. We've done it, right? Milestones are things you tick off on the way. Outputs. Yep, we actually have got a chemical that does seem to distinguish lanthanides and actinides. That's a good output, right? Must have, well, we've decided that it must be safe, it mustn't poison people, and that seems to be the case. Should have, well, people have said to us it would be really nice if this chemical was not too volatile, but sufficiently volatile so that we could separate it by evaporation. Okay. So you have a number of targets, a number of parameters. Okay. And remember I said you might have done a feasibility study, and 8 out of 10 things really work well, which means 2 things you're worried about you've identified as the major risks. So at every point you say, what have we done about those risks? What action have we taken? Are those risks still there? We identified one risk, that we're developing a piece of software and we think Microsoft are interested in the market. And we might not want to compete head-on with Microsoft. What's the latest news about that? Okay. And we then look at the plan for the next stage. What will we do? What are the tasks? What are the milestones? What's it going to cost? And then we make the decision. Given all that, is it still worthwhile doing the project? And that's the job of the managers. Right? The job of the managers is to help people make good decisions. And by making good decisions, that includes backing good projects, but it also includes stopping bad projects. The companies that are good at project management are good at stopping bad projects, right? And the key thing is, because they have this system, because they know which circumstances would cause them to stop the project, it is possible to stop the project and distinguish between two situations. We might stop the project because of factors outside our control. We might stop the project because we anticipated that Microsoft might be a problem. We anticipated that the potential ligand we've got might have a toxicity side effect, and it does. We anticipated that. It's no one's fault, right? We did what we could. And we want to distinguish that from, actually, we were just idle and goofed off and did no work, right? We were just incompetent. Right? It would be nice, wouldn't it, if we had this level of transparency on our current trams project, wouldn't it? It would be nice if we could see these things. And that's actually the job of the senior managers. It's not their job to run the project, it's their job to take good decisions and to make it clear why we are or why we're not stopping a project. Yeah? That's what this slide is about. Right? Don't blame people when stopping projects. Stopping a project for a good reason is great. The people who've been on a project that hasn't quite worked are actually a really useful resource. Right? Most of us don't learn from our successes. We just accept them as our God-given right because we're so clever. Most of us learn from our failures, don't we? Right? I'm never going to do that again. I'm never going to drink that number of pints. I'm never going to drive my car. You know, we learn from our failures. Actually, one of the biggest resources in any organization, the people who've worked on a project that hasn't succeeded and know why. Okay? And if you are a senior manager, say an R&D manager, a company like HP, you have a portfolio. You know, you've got 30 projects in the idea stage, you've got 10 feasibility studies, you've got 7 in fairly detailed planning and proposal stage, you've got 3 full projects going on, 3 complete or in knowledge transfer. One of the interesting things that Robert Cooper came up with was some statistics of how many projects you need to do to have one commercial success. And it's broadly like this. You need 50 ideas to generate 7 to 10 development projects to get one commercially successful product or service, right? 50 to 10 to 1, that's the typical ratio. Right? And there are ways to improve that, but it's a pretty good rule of thumb. How do you run the project? What are the lessons? One of the key things is you actually have someone in charge. Okay? You actually have a project manager. You need someone who is accountable for the project. And one of the problems that lots of organizations have who are not good at project management is they hate doing this. They hate putting a project manager in across a boundary. And some of the organizations that are not good at doing this do include universities. The project manager needs to plan things, needs to break down the activity into tasks, subtasks, and ideally can break down the activities into person-sized tasks and subtasks. And everyone in the project knows what they're doing. Everyone in the project is effectively being supplied by someone else or working for someone else. It's as if they have a sort of customer-supplier relationship. And in a good project, every individual working on it should have a list of their tasks and why they're doing it. And the project manager will spend some time. You'll hear this acronym called SMART tasks. Make the tasks specific, make them measurable, agree them, make them achievable, right? Make them realistic, and make them timed. I want you to do this feasibility study. How long do you think it's going to take you to do? 3 months? Okay, you've got 4 months, and I want it by then. If it's not working, come back and tell me. And a large part of the job of the project manager is making things clear to everyone, making it clear what they're expected to do. Everyone on the project should know, what's my principal task or subtask on the team? I'm the crystallographer, I've got to make crystals, okay? Why, who am I doing it for? Well, some people need to know the structure of this candidate drug. Okay? When do they need it, and why do they need it then? Well, they need it by the autumn, because unless we know the candidate drug, unless we know the structure, we can't put in the paperwork for doing the preclinical trials, let alone the clinical trials. What targets and standards must be set? You know, how good does the work need to be? Is it okay if I kind of pretty well have a good guess on what the structure is? Or do I really, really need to know down to conformational details? What are the main things I need to do the project? Okay, I'm a crystallographer. Well, I need some good crystals. Perhaps that's my skill. Perhaps I have someone on my team that's good at growing them. I might need equipment. I might need computing. Okay, who's supplying that to me? Do they know why I need it? Do they know when I need it? And do they know why I need it when? Statement with lots of W's in, right? And actually the job of the project manager is just making sure everyone knows all that stuff. They used to train us in project management at my old employers by making us do endless games, building model aeroplanes out of paper clips, right? Building towers out of dried spaghetti and pasta, and watching the way that we worked as a team. And you didn't get picked to be a manager for shouting at the others. You got the people they wanted to be managers were the ones who said things like, are you sure you're doing that right? Do we actually know what we're doing here? Has anyone done this before? Right? Those kind of questions. Coordination skills, very important for a project manager. And what you find, one of the jobs of the project manager as the project grows is to put it into a flowchart. All of those different tasks. And there's another bit of project management jargon which is called dependencies. Right? We can't submit the documents for approval unless we know the structure. Okay? That's a dependency. We have to have the structure totally elucidated. Okay? So you get things like, we can't start the task until we've finished. Right? You get these kind of things. Right? And one of the jobs of the project manager is to draw little flowcharts of the project. And some projects will look like this, a nice straight line, but many projects will look like this. This was the flowchart that I did, a part of a feasibility study for a project developing a new piece of medical hardware. Right? And all the blue things on the left is the technical development program, and all the green things on the right is the commercial discussions that we're having in parallel. Remember I said these take years as well. All of the red things in the middle are joint activities, and all of the lines are dependencies. And you can see dependencies from the left to the right, from the right to the left. And that's what real projects typically look like. And then the question is, how long is all that going to take? What's that going to cost? And that's where we use project management software. Right? I mentioned Gantt charts and PERT charts earlier. There is software that helps you set out, produce nice flowcharts, and it helps you calculate how long the project will take. What it doesn't do is do the flowchart for you. You still have to work out all of the dependencies, all of the tasks, right? It's classic rubbish in, rubbish out. Right? Microsoft make one, of course, called Microsoft Project. A number of other people make them. Broadly, what you have is a form to fill in, and it says what are the lists of tasks and what other tasks does this depend on. What you generate are two outputs. One is a thing like this, which is a project scheduling task. It's a little picture, a graphic of what is happening at what point in the project. This thing goes way back to the 1920s. It was invented by a Mr. Gantt. Lots of grant applications now need a Gantt chart. They ask for Gantt charts, okay? And it basically is a map of tasks against time, and it's easy to see what's going on. The other one you have is the flow chart for the project, a little map of the project. This is the thing the Americans invented in the 1950s, the project evaluation and review technique. It shows the task dependencies, and the nice thing about the software is when you're faced with that messy flowchart, it can calculate what they call the critical path. For us chemists, it's like the rate determining step, right? You have a series of rate determining steps taking you through that flowchart, right? The steps on the red line, you can't afford to delay, because that will delay the whole project. It is actually pretty important to know what the critical path is in a project, right? The good software will actually let you write down not just the task, but who's going to do it. And then it will calculate how busy that person is going to be. Right? It won't let you put 150% of a person's time on. I do remember talking to a guy at one of our research institutes here in Scotland, and we used this to prove that in order to meet the deadline his boss had asked, we would have to clone him 7 times over. Sadly, we weren't at the Roslin Institute, which could have made it feasible, and so he wasn't going to be able to meet that deadline. Okay. There's loads of these things. There's loads of project management tools and software. Microsoft Project, us Mac users, there's one called Merlin. I mean, it used to be for buildings, right? Architects were the first people to get it. It used to cost 20 grand, and now you can get it as shareware. I quite like a program called AEC Fast Track, if only because they let you download the whole software for free, and they let you play with it, and it has worked examples, and that's what one of their examples looks like. And that's the screenshots, that's the calendar view, and it integrates with Excel so you can do budgets. And you can, what you do have to remember, I have seen people making beautiful Gantt charts. It's quite good to make beautiful Gantt and PERT charts because its bosses love it. It's this great boss management tool. Are you in control? Yes, of course I am. Here's the Gantt chart. Investors love it. Oh, they must know what they're doing. They've got a Gantt chart. Okay? But like I say, it can be rubbish in, rubbish out. I have known project managers spend all their time playing with the software and not actually being the project manager. If it's a big project, what you need is a bright, young, enthusiastic, geeky kind of person to run all of the PM software while you manage the project. Final couple of slides, which is about risk. Okay. I talked about, we identified 10 critical factors. 8 of them we look clear on. 2 of them might be a risk. Okay, what are we going to do about that, apart from the Clint Eastwood approach? Okay. We can systematically spot risk. One of the ways, and I have done this for an organization, it was a computer games company. They said, we have a lot of projects that fail? Can you tell us why? Can you tell us how to bring some management grip on the subject? And what we did was we got all of the people who'd ever worked on a failed project and brought them into the same room. They were panicked because they thought we were going to sack them. And instead, we spent 3 days just brainstorming everything that had ever gone wrong with any project they'd ever done. We got 300 post-it notes, which we got them to stick on the walls of the building. Right? And my job was to take away the 300 post-it notes and clump them together, come back with a kind of risk factor map. And their risk factors varied from very technical things, like we're not terribly good at asynchronous computing, whatever that is, to actually quite human factors. Do you know, we've never had a successful project where Bob and Bill have been on the same team. They just hate each other. Okay, so one of the risk factors I put in was, are there any potential personality issues on the proposed project team? And I came back with that, and everyone said, you mean Bob and Bill, don't you? And I said, well, we're not, it could be other people, right? And you can do that stuff. Yeah. You can be very systematic. That's one of the slides that we helped to develop. IBM, there's a lot of stuff about this. IBM have a series of factors that they add to the proposed development time of the project. An effort multiplier. How many years has the team got? If the team has fewer than 4 years, it's going to take longer than you think. Yeah. If the type of environment that you're on can change things. I mean, the classic risks in projects, because I get asked to do feasibility studies a lot, right? And the classic risks in projects, if it's medical technology, whether it's devices, whether it's diagnostics or therapeutics, it always takes more time than you think, and it always costs more money. For environmental and renewables, there's always the tension between who gets the benefit, all the people who don't get polluted by the factory, and the people that you're actually asking to pay for it. You're asking factory owners to put in anti-pollution technology that doesn't actually change their lives. We're in competition. We're a small startup. Do you have any competitors? Well, we're in competition with Microsoft, but we can beat them. Really? They've got 200 people working on this. I'm kind of worried about some of the activities that are going on in Scotland on stem cells. I'm sure they're very good, but I have heard that the Chinese have whole research institutes just doing stem cells, and that worries me. Someone's published it, and we can't patent it. And time to sell to big customers. As I said earlier, we are talking with Glaxo does not mean we're having a chat with a man from Glaxo in the pub. It means proper negotiations. Ending the project, we stop it. One of the things that we do is we do stop projects either because they work or because they don't work. We know why we stop them. And what we always do is write down a list of what we would do better next time. Yeah. And it doesn't matter whether it's a project that did work or a project that didn't work. In the good organizations, you always have a post-project review. You always say, what did we do well? That really worked. What did we not do so well? And because you have that meta process, that stage gate, you take the lessons from your project and you put it back into your overall methodology. Yeah? Okay. Unless there are any questions, I will thank you for your attention. I have just telescoped the 2 weeks on how to be a project manager into just over an hour. So thank you very much for your attention, and I hope you found that interesting.